Today we are going to be talking about the three ways that remove a functional group by reduction from the carbon double bond to an oxygen into a CH2 molecule. The first reaction is Wolff-Kishner, then Clemmensen, and finally Raney-Nickel reduction.
So we're going to talk about how a simple mechanism for taking a carbonyl group and turning it into a methyl group. In the first section, group steps area, you're going to have several steps like you would form a normal amine group. And so in this step, you would take this hydroxide, this lone pair right here, and come and grab the hydrogen. The hydrogen would kick off right there. And then you would form this structure, and through resonance, you would get this lone pair, which would come and grab this hydrogen. Hydrogen would kick off onto that oxygen. Then over here, you kind of like a reverse kind of a thing, where these electrons come and grab that hydrogen, and then this bond is going to kick off onto this double bond, and then this becomes a really good leaving group, so it'll kick down from this carbon right here, leaving this lone pair. This lone pair then can come grab the hydrogen, which will kick off from this hydroxide group. So then you have your final product, the nitrogen gas, and this hydroxide group.
In the Wolff-Kishner reduction, the Clemmensen reduction, and the Raney-Nickel reduction, you'll notice that there are some similarities and some differences. Some of these similarities include the reactants, which are ketones and aldehydes, and the products, which is a CH2 group. In all three of these reductions, our carbonyl group is converted into a methylene group. One of the differences you'll notice in these reductions is in their respective reagents. In the Wolff-Kishner reduction, the reagent is hydrazine. In the Clemmensen reduction, the reagent is an alloy of zinc and mercury, and in the Raney-Nickel reduction, the reagent is Raney-Nickel after it has first been treated with a thiol under acidic conditions. Another difference you'll notice in these reductions is in their respective conditions. With the Wolff-Kishner, the reduction will take place under basic conditions such as with KOH. For the Clemmensen reduction, this reaction will take place under acidic conditions such as HCl, and with the Raney-Nickel reduction, this will take place under mild conditions. There are some limitations to these reductions. The Wolff-Kishner reduction should be avoided if there is a functional group that is able to react under basic conditions or with a good nucleophile. The Clemmensen reduction should be avoided if there is a functional group that can react under acidic conditions, and there's also the worry that mercury is just dangerous to work with. For the Raney-Nickel, it should be avoided if there is a functional group that can react with nucleophilic thiols, or H2, in the presence of a metal catalyst.
In conclusion, we talked about the Wolff-Kishner reduction and how it uses aldehydes and ketones in order to form alkanes. Then we talked about the Clemmensen reduction and how it uses zinc as the reducing agent. Finally, the Raney-Nickel reduction and how it will add a hydrogen in the syn fashion in order to obtain a methylene group. We also discussed the limitations of each, so here's a short summary. The Wolff-Kishner should be avoided if one of the functional groups present will react under basic conditions or with a good nucleophile. The Clemmensen should be avoided if there is a functional group present that is reactive under acidic conditions. And lastly, the Raney-Nickel reduction should be avoided if there is a functional group that is reactive with nucleophilic thiols or with H2 in the presence of a metal catalyst.